Hi, today I would like to talk about how to add these two fractions, 3 over 10 plus 7 over 100. I would like to discuss this very specific example. Just as a quick review, we said the sum of these two fractions is another fraction which we think of as the length of a long segment, that is the concatenation of a short segment of this length and another short segment of this length. That's the definition of addition of two fractions. And yet we ask, well, what are the specifics? When I add these two fractions, I get a fraction. Now, what is that fraction really? I understand it's the length of the long segment, but I would like to know what fraction it is. We discussed the fraction addition formulas, into which are packed the specifics of how to actually go about carrying out the addition. And you will recall these two fraction addition formulas. Here A, B, C, D are whole numbers, and we do not want the denominators to be 0. That's what that one specifies. This first addition formula tells us how to add two fractions with the same denominator, and this one tells us how to add fractions with different denominators. The fundamental fact about equivalent fractions was used to derive this addition formula. So we look at this problem, 3 over 10 plus 7 over 100, and we recognize the denominators are not the same, and so we think we should use addition formula too. And you're correct, we can use this to find the sum. There's also an alternate method to doing this, so I want to discuss both the methods on the other board. So here in method 1, I have directly applied the addition formula. 3 over 10 plus 7 over 100 is another fraction whose denominator is simply the product of these two denominators, 10 times 100, and the numerator is 3 times 100 plus 7 times 10. So, and then I continue writing out the steps. I arrive at 370 over 1000. I recognize that both numerator and denominator have a common factor of 10, and by cancellation law I can cancel out that common factor of 10 and arrive at 37 over 100. So 3 over 10 plus 7 over 100 is 37 over 100. So in this special case, we right away notice actually a relationship between the two denominators. 10 is a factor of 100, or 100 is a multiple of 10. So we notice that. And in such situations, we can proceed as follows, and the steps are fewer. So I would like to discuss that. So what do we do here? We notice that we cannot add the two fractions right away because of the uncommon denominator. So then what we think is, since 10 is a factor of 100, we could replace 3 over 10 by an equivalent fraction. So by applying the fundamental fact about equivalent fractions, we multiply numerator and denominator by 10. So now we have 30 over 100 plus 7 over 100, two fractions with the same denominator. And then we can add using the addition of fractions formula 1 and add the numerators 37, and the denominator is still the common denominator, and we get 100. So both of the formulas do use fundamental fact about equivalent fractions. Here we use what we did was we applied the addition formula, addition of fractions, the formula 2, which used fundamental fact about equivalent fractions 2 times to adjust both the denominators. And here we only adjust the denominator of one of the fractions. So you might choose to proceed in this manner for these special situations where one of the denominators is a factor of the second denominator. The steps are fewer. Or you can simply choose to go with only the addition of fractions formulas that I discussed, 1 and 2, and you could proceed this way. And if you do so, you'll still arrive at the same answer once you cancel out the common factor. So that's all. Thank you.